All right, so we've been talking about complex numbers. Let's look at this next problem. It's similar to the last one we did. Now be careful here. We want to get rid of the I in the denominator. The I in the numerator won't be a problem, but we need to get rid of it in the denominator, so we're going to need to use the conjugate. So for negative 7 plus 2i, the only difference in the conjugate is it'll have a minus in the middle. And so let's go ahead and multiply by negative 7 minus 2i over negative 7 minus 2i. So again, we're multiplying our denominator by the conjugate. And whatever we do to the denominator, we're going to have to do the same thing to the numerator. Basically, all we're doing is multiplying by something that's equal to 1 here. And that's going to enable us to simplify this so that it's in the form a plus bi. All right, so let's see. We have 5 minus I times negative 7 minus 2i. In the denominator, we're going to have negative 7 plus 2i, and that's multiplied by negative 7 minus 2i. So we're going to be doing a bunch of foiling here. So 5 times negative 7, we get negative 35. When we multiply our outer product, that'll be negative 10i. The inner product will be a plus 7i. And the last product will be, let's see, minus I times a minus 2i will be a plus 2i squared. Now in the denominator, all we have to do is multiply this minus, well, the first terms and the last terms. So we'll get negative 7 times negative 7 is 49. And then a 2i times a negative 2i will be a minus 4i squared. Now in the numerator, we have negative 35. And because of the I squared, that's going to be 2 times negative 1. So negative 2 and negative 35 is negative 37. And then a minus 10i and a plus 7i are going to be a minus 3i. In the denominator, remember that I squared is negative 1. So we're going to take 49 and add 4, and so we're going to get 53 here. Now again, don't forget, we want to write this in that form, a plus bi. And so this will be negative 37 over 53 minus 3 over 53 times I. All right. So the next thing I want to talk to you about is just powers of I. It turns out there's something interesting that happens with these. So let's see what's going on here. Actually, first I'm going to rearrange things a little bit to make some room. So I is just I. What about I squared? Well, we know that's equal to negative 1. What if we try I cubed? So we're looking at the powers of I. We want to see what's going on here. What are we going to get? So this is really I squared times I, or we could write it that way. And we know I squared is negative 1. And so this is minus I. So let's look at I to the 4th. We could write that as I squared times I squared. And those are both negative 1. Negative 1 times negative 1 is going to give us a positive 1. And finally, let's go one more time. If we do I to the 5th, we know, well, we could write it as I to the 4th times I. And we just said I to the 4th is 1. And 1 times I is I. So notice we're back to where we started. And in fact, the pattern would continue. So we have I, then negative 1, then a minus I, and then positive 1. So every power of I is going to equal one of these 4 numbers. All right, so let's see how this works. So you'll have to do this in the homework. Really, you could use any of these powers, I to the 4th, I cubed, or I squared to help you break these problems down. But I'm going to do it this way. There's more than one way to do these. So I'm going to think, okay, what's the highest I squared power that I can get that's going to be either give me 7 as an exponent or smaller? Well, I squared cubed is I to the 6th, so I need to multiply by an I. Well, what is I squared? It's negative 1. So we have negative 1 cubed times I. We know when we multiply an odd number of negative 1s, we're going to get negative 1. Or when you multiply 3, you're going to get negative 1. So we're going to get a minus I here. All right, so I would encourage you to try B. It's actually probably easier than the one I just did. All right, so I would say I squared to the 21st power. Remember, we're using the power rule. When you have a power to a power, you multiply the exponents. And so, well, we know I squared is negative 1, and if you multiply an odd number of negative 1s, you're going to get negative 1, and that's it. All right. Now, this last problem is one I would like to challenge you with. It's the kind of thing we're going to run into when we deal with polynomials. And so let's see if you can take what we've done and the skills you already have to do that problem. Give it a shot. All right, so let's see how you did. Now there's two ways to do this. I'm going to do it the way that I think is a little bit easier, and I'll just point out how else you could do it. And so what I'm seeing here is my first terms, my second terms, both of them separated by a minus. So what we have here is two binomials, although one of our terms is actually a binomial. So I'm going to FOIL this. All right, so I'm going to multiply the x terms, and I get x squared. That's my first terms. Let's multiply the outer terms. We have x times a minus quantity 3 minus 4i. So that'll be minus x times the quantity 3 minus 4i. Our inner product will be minus x, since it's a negative times a positive, times the quantity 3 plus 4i. And our last product, it's going to be a negative times a negative, and we're multiplying these two binomials. So let's go ahead and simplify this. I know it's quite a mess. We have x squared, and then I'm going to distribute here. I'll get a minus 3x and a plus, and I'm going to go ahead and put the I last, so plus 4xi. And then we have a minus 3x and a minus 4xi. Now this last product here, I'm going to do it off to the side just to make my work a little bit easier here. You might be able to do it in your head. So when we multiply the first terms, we get 9, and the last terms, we get a minus 16i squared. We can do that because these are conjugates. If you multiply this product and this product, they're just opposites. They add up to 0. And so we have 9 plus 16, because remember I squared is negative 1, and so this is just 25. And so we have a plus here, so it'll be plus 25. Now let's see, what do we have here? We have x squared. We've got a minus 3x and another minus 3x. That's minus 6x. Notice these I terms cancel each other out, and then we have a plus 25. All right, so if you got that answer, it doesn't matter how you got it, that's good news. Notice we're doing a little bit of algebra here. Now the other way you could do this is you could start by distributing inside each of these two binomials. And so I could write the first one as x minus 3 minus 4i, and the second one as the quantity x minus 3 plus 4i. Now keep in mind, if you do it this way, you're going to have to multiply x times each term here, and then you'll do the same thing with negative 3, and then the same thing with negative 4i. And so you are going to get 9 terms when you do that, but you should get the same answer. All right, let's go ahead and stop right there.